Welcome to The Explainer. Today, we're diving into one of the absolute most fascinating challenges in modern AI. We're going to look under the hood to see exactly how these systems actually get their facts straight, and maybe more importantly, how they access current factual information when the world around them is just constantly changing. So I want you to really think about this for a second. How exactly does an AI model, one that was trained months or, hey, even years ago, suddenly know how to answer questions about this morning's breaking news or, the latest unreleased earnings report from your company? It's kind of a massive contradiction, right? The underlying technology hasn't been updated at all, and yet the answer changes?
And this brilliantly illustrates the core thesis of our entire explainer. There's this fantastic quote from systems architect Tom Archer that just perfectly captures the magic trick here. When an AI answers a question about current events, it didn't magically learn anything new. There is a fundamental, massive difference between what a model learns during its training and what a model reads right before it answers you.
To make sense of all this, here is our roadmap for today. First, we'll cover the frozen AI problem. Then, enter Retrieval-Augmented Generation. Next, how the RAG pipeline works. After that, RAG versus fine-tuning. And finally, we'll wrap up with the hybrid AI future. Okay, let's dive right into this with Section 1, the frozen AI problem. Specifically, why standard LLMs completely fail at current events. That is $100 billion. Let that sink in. That's the amount of market value Alphabet, Google's parent company, lost in a single day when they first demoed their LLM tool, Bard. The model confidently hallucinated a totally incorrect fact about the James Webb Space Telescope. So this wasn't just some minor glitch. It proved in real time that AI hallucinations have catastrophic, very real-world financial costs. And the reason that $100 billion mistake actually happened comes down to these standard limitations. See, when an AI finishes its training phase, its internal parameters, its weights are permanently frozen. It has a strict knowledge cutoff. So if you ask it about your private enterprise data or even just something that happened last week, it doesn't just politely say, "I don't know." Because it's a probabilistic token generator, it often guesses, it hallucinates, inventing these highly plausible but entirely fake details. Plus, the whole thing operates as a black box, so you literally cannot verify where its answers are coming from. Which brings us to Section 2, enter Retrieval-Augmented Generation. This was a massive 2020 architectural shift designed to solve a huge issue. The model's brain is frozen, but the world keeps moving. This is Retrieval-Augmented Generation, or RAG for short. It was first introduced in a seminal 2020 paper by Lewis, and Wikipedia defines it beautifully right here. But in practice, what this actually means is taking the AI's internal, frozen brain, the parametric part, and basically bolting on an external dynamic hard drive, the non-parametric memory. And the AI can search through that hard drive at the exact moment you ask it a question. Honestly, the best way to think about this is comparing a closed book exam to an open book exam. Fine-tuning a model is like studying for months to memorize facts for a closed book test. The knowledge is just baked right into your brain. But RAG is taking an open book exam. The AI is dynamically looking up external notes during the test. It doesn't need to re-memorize the entire internet every single time a new article is published. It literally just reads the new notes. Let's move to Section 3 and see how this builds, how the RAG pipeline works, which is all about writing and reading the notes. So this happens in two main stages. The first is the indexing pipeline. You can think of this as the offline writing process. Imagine you've got a massive 50-page PDF of company policies. RAG first chunks that document, literally splitting it up into smaller, meaningful pieces. Then it uses an embedding model to convert those text chunks into dense, numerical vectors based on their semantic meaning. Finally, it stores these vectors in a specialized vector database. It's essentially organizing a gigantic library so it can be searched instantly. Then, the second stage kicks in the exact moment you ask a question. This is the real-time reading process. When you ask something like, "What is our new refund policy?" the system converts your question into a vector too. It runs a similarity search in that database to find the chunks of text that mathematically match your question. It grabs those exact chunks, stuffs them right into the prompt as context, and basically tells the AI, "Hey, answer the user's question, but base it only on these retrieved notes." So the crucial point to remember here is that the AI hasn't learned a single new thing. The model is simply applying its frozen, pre-trained pattern matching and reasoning skills to this newly retrieved text.
It is just reading. The inputs themselves are totally dynamic, and that gives us the illusion of this constantly updated, hyper-intelligent model. Moving into Section 4, RAG versus fine-tuning. This really is the ultimate 2026 enterprise question that development teams are facing right now. A lot of the debate around this usually stems from a basic misunderstanding of what each tool actually does. RAG is designed strictly for injecting facts and external dynamic knowledge to kill those hallucinations. Fine-tuning, on the other hand, is about adapting the internal behavior of the AI. It's about teaching the AI a very specific brand voice, a strict regulatory tone, or how to reliably output complex code structures. Simply put, one is for facts, the other is for behavior.
Consider the decision matrix aggregated from Scalar and Future AGI. You might even want to save these rules. Notice data freshness. If your data changes daily, RAG is for sure the only way to go. Then look at the audit trail. RAG gives you exact citations pointing back to your source documents, whereas fine-tuning leaves absolutely no trace. And finally, computational cost. RAG is incredibly cheap because you're just generating embeddings, while fine-tuning requires really heavy, super expensive GPU training.
So let's distill all this down into 3 practical rules you can take away today. Rule 1, if your knowledge changes weekly, we're talking product specs, pricing, support tickets, that belongs in RAG. Rule 2, if you need a specific tone or output format, and no matter how much you tweak the prompt, the AI just keeps drifting, that behavior belongs in fine-tuning. And rule 3, when in doubt, just do both.
Which leads us perfectly into Section 5, the hybrid AI future, combining the absolute best of both worlds.
Now, what's really interesting about this setup is how elegantly these technologies snap together. Developers today are taking highly efficient, smaller models, like Llama 4.x, and fine-tuning them on the cheap, using techniques like LoRa. This basically bakes in the perfect corporate tone and exact formatting. Then they literally layer a RAG stack right on top of it. So when a user asks a question, the system retrieves the fresh facts, feeds into the fine-tuned model, and boom, you get an answer with perfect facts and perfect formatting. You then evaluate this entire system as one unified product, checking metrics like context relevance and faithfulness to make sure everything is humming along perfectly. But I do want to leave you with a critical warning here, because RAG is not magic. Remember our vector database from earlier? Semantic similarity only measures relevance. It does not measure correctness. Garbage in, garbage out. There is this famous example documented by MIT Technology Review where an AI confidently stated that Barack Obama was a Muslim president. Why? Because it retrieved a rhetorical chapter title from a book that literally read, "America's First Muslim President." The chunk of text was semantically highly relevant to the search query, but the AI completely missed the rhetorical context. If you feed the system garbage, it's going to confidently cite that garbage right back to you. Which brings us to our final thought. We've established that the most powerful way for an AI to get its facts straight is to take an open book exam using your documents. But if the AI's truth is entirely dependent on the notes it retrieves, how clean is your data? Something to think about. Thank you so much for joining me for this explainer, and we will see you next time.